Look up at the night sky, or sometimes in the fading light of dusk, or the gentle glow of dawn. You might see a brilliant point of light. Not twinkling like a distant star, but shining with a steady, serene radiance. This is often the planet Venus. It can be so bright. It is the brightest natural object in our sky after the sun and moon. Ancient peoples saw it. They marveled at its beauty. They gave it names associated with love and splendor. This celestial gem has captivated human imagination for millennia, a beacon in our cosmic neighborhood. For a long time, people thought it was two different objects. One that appeared in the evening, they called Hesperus. This was the evening star. Another that appeared in the morning, they called Phosphorus or Lucifer. This was the morning star. It took careful observation. It took the dawn of methodical astronomy. Thinkers like Pythagoras are credited with realizing these were one and the same. This single wandering star was not a star at all. It was a world, a planet, moving in its own path around our sun just like Earth. This realization was a profound step. It helped us understand our place in the cosmos. Venus orbits closer to the sun than Earth does. So, from our viewpoint, it never strays too far from the sun in the sky. This is why we only see it for a few hours after sunset, or a few hours before sunrise. It dances around the sun, sometimes visible, sometimes hidden in its glare. Its phases, like our moons, were famously observed by Galileo Galilei. This was strong evidence for the sun-centered model of the solar system. Venus, a name that evokes images of beauty, a name given by the Romans for their goddess of love. But this world is not what its lovely name might suggest. It is a place of extremes, a place of fiery torment. It's a world shrouded in mystery. Its bright clouds hide a surface unlike anything we could have imagined. This brilliant beacon in our sky invites us to explore. It beckons us to uncover the secrets hidden beneath its shining veil. Come, let us journey to this enigmatic world. Venus is often called Earth's twin, or sometimes Earth's sister planet. This is not without reason. When we look at the basic statistics, the resemblance is striking. Venus and Earth are remarkably similar in size. Venus is just a little smaller. They are similar in mass. Venus has about 81% of Earth's mass. They are made of similar stuff. Both are rocky, terrestrial planets. They formed in the same neighborhood of the early solar system. They are in many ways cosmic siblings, born from the same protoplanetary disk. These similarities led to many dreams. For centuries, even into the early space age, people wondered, could Venus be a lush tropical paradise, perhaps a younger Earth teeming with exotic life? Science fiction writers imagined vast oceans. They pictured dense jungles beneath its perpetual cloud cover. Maybe dinosaurs still roamed there, or strange alien civilizations thrived. The thick clouds hid its surface. This allowed our imaginations to run wild. It was a tantalizing prospect, a sister world, perhaps a haven for life. But when our space probes finally pierced the veil, the reality was shocking. Venus is no paradise. It is a hellscape. The beautiful clouds are made of sulfuric acid. The surface temperature is hot enough to melt lead. The atmospheric pressure is crushing. It is more than 90 times what we experience on Earth's surface. This is like the pressure found nearly a kilometer deep in our oceans. This is not Earth's gentle twin. This is Earth's fiery, inhospitable sister. A world that took a drastically different path in its evolution. So what happened? Why did these two sister planets, born so alike, become so different? This is one of the greatest mysteries in planetary science. Earth became a vibrant, living world. Venus became a scorching, barren inferno. Understanding this divergence is crucial. It tells us about the delicate balance that makes a planet habitable. It teaches us about the forces that can shape a world's destiny. The story of Venus is a cautionary tale. It is a story written in the language of planetary evolution. Let's delve deeper into these initial similarities. Imagine Earth. Now imagine Venus next to it. Visually, they would look like very close siblings. Earth has a diameter of about 12,742 kilometers. Venus is just slightly smaller, with a diameter of about 12,104 kilometers. That's about 95% of Earth's size. This is a remarkably close match in the grand scale of the solar system. Planets come in all sizes, from giant Jupiter to tiny Mercury. Finding two so closely matched in size is significant. It suggests they had similar amounts of building material available when they formed. Now let's consider their mass. Mass is the amount of stuff an object is made of. Earth's mass is about 5.97 sextillion metric tons. That's a huge number. Venus comes in at about 4.87 sextillion metric tons. This is roughly 81.5% of Earth's mass. Again, very similar. This similarity in mass means that the gravity on the surface of Venus is also comparable to Earth's. If you could stand on Venus and survive, you would feel about 90% of the gravity you feel on Earth. You'd be a little lighter, but not dramatically so. Density is another important factor. It tells us how tightly packed the material is. Earth's average density is about 5.51 grams per cubic centimeter. Venus's average density is about 5.24 grams per cubic centimeter. Once more, these values are very close. This similarity in density, along with their size and mass, strongly suggests they have similar overall compositions. Both planets are understood to have a rocky crust. They have a silicate mantle, and they have a metallic core, likely made of iron and nickel. They are terrestrial planets through and through. These fundamental similarities in size, mass, and density paint a picture. They show two planets that started out on very similar footing. They are like two seeds from the same cosmic pod. They were given almost identical starting conditions, yet their evolutionary paths diverged dramatically. This makes the stark differences we observe today even more profound. It transforms Venus from just another planet into a crucial natural laboratory, a place to study how planetary environments can evolve in vastly different ways. The puzzle of Venus deepens. The atmosphere of Venus is nothing like Earth's breathable air. It is a thick, choking blanket. It is composed almost entirely of carbon dioxide. About 96.5% is CO2. Nitrogen makes up most of the rest, around 3.5%. Earth's atmosphere, by contrast, is mostly nitrogen and oxygen. This overwhelming abundance of carbon dioxide on Venus is the primary driver of its extreme climate. This dense gas traps heat with incredible efficiency. It's a planet-wide suffocation. Imagine an atmosphere so heavy it presses down with immense force. This leads us to something called the greenhouse effect. You've heard of it on Earth. Sunlight, which is shortwave radiation, passes through the atmosphere. It warms the planet's surface. The surface then radiates heat back outwards as infrared radiation, which is long-wave. On Earth, greenhouse gases like water vapor and carbon dioxide trap some of this outgoing heat. This keeps our planet warm enough for life. It's a delicate balance, but on Venus this effect has run completely out of control. It is a runaway greenhouse effect. What does runaway mean? It means a vicious cycle, a positive feedback loop. Early in its history, Venus might have had oceans like Earth. As the sun grew slightly warmer, more water would have evaporated. Water vapor itself is a greenhouse gas. This trapped more heat. This caused more water to evaporate. Eventually the oceans may have boiled away entirely. The carbon dioxide, perhaps locked in rocks or oceans initially, was released into the atmosphere. With no oceans or active geology like Earth's plate tectonics to sequester it, the CO2 built up. More CO2 meant more heat trapping. The result of this runaway greenhouse effect is a surface temperature averaging around 465 degrees Celsius. That's about 870 degrees Fahrenheit. This is hotter than the surface of Mercury. Even though Mercury is much closer to the Sun, lead melts at 327 degrees Celsius, zinc melts at 419 degrees Celsius. So, on the surface of Venus, these metals would exist as puddles. This extreme heat is maintained across the entire planet. From the equator to the poles, day and night, there is no escape from the relentless baking heat under Venus's thick carbon dioxide sky. Section 5. Beneath the clouds, glimpses of a hellish landscape. Venus is perpetually shrouded in a thick layer of clouds. These are not fluffy white water clouds like on Earth. These clouds are made primarily of droplets of sulfuric acid. Yes, the same corrosive substance found in car batteries. These clouds extend high into the atmosphere from about 45 to 70 kilometers above the surface. They reflect about 75% of the sunlight that hits them. This is why Venus appears so bright in our sky, but they also make it impossible to see the surface with ordinary telescopes. Imagine looking up from the Venusian surface. You would see a dull, yellowish, overcast sky. No sun, no stars, just an oppressive, acidic haze. So how do we know what the surface looks like? We use other kinds of light. Radar waves can penetrate the clouds. In the 1970s and 1980s, the Soviet Union achieved a remarkable feat. They sent a series of landers, the Venera missions, to the surface. These probes survived only for a short time, some for less than an hour, some for a little over 2 hours, but they managed to send back the first and only images taken from the surface of another planet besides Mars. They also analyzed the composition of the rocks before succumbing to the extreme heat and pressure. Later, NASA's Magellan spacecraft, an orbiter, used powerful radar. It mapped about 98% of the Venusian surface in stunning detail. What did it reveal? A volcanic world. Vast plains of solidified lava cover about 80% of the surface. There are thousands of volcanoes. Some are shield volcanoes, similar to those in Hawaii, but much larger. There are also unique volcanic features called coronae and arachnoids. These are circular or web-like structures possibly formed by upwellings of hot material from the mantle. Impact craters are also present, but fewer than on Mercury or the Moon. This suggests the surface is relatively young, geologically speaking. The pressure on the surface is immense. It's over 92 times Earth's atmospheric pressure at sea level. This is equivalent to the pressure you would experience if you dived nearly 1 kilometer deep into Earth's oceans. The Venera landers had to be built like deep-sea submersibles to withstand it. Even then, they were crushed and cooked in a short time. The combination of crushing pressure, searing heat, and corrosive atmosphere makes Venus one of the most inhospitable environments in the solar system. A true vision of hell. Section 6. A World of Fire. The Turbulent Geology of Venus. Beneath its dense atmosphere, Venus is a rocky world, much like Earth. Its internal structure is thought to be similar. It likely has a metallic iron-nickel core. This core might be partially molten, like Earth's. Surrounding the core is a thick mantle of silicate rock, and on top, a rocky crust. The building blocks are all there, the same raw materials that formed Earth. Yet, the geological expression on its surface appears quite different from our dynamic planet. The story written in its rocks speaks of a fiery and perhaps still active past. Volcanism has clearly played a dominant role in shaping Venus's surface. The radar maps show extensive lava flows. There are vast volcanic plains. Thousands upon thousands of volcanoes dot the landscape. These range from small shield volcanoes to towering edifices like Mont Mons. Mont Mons is one of the largest volcanoes on Venus, rising about 8 kilometers above the surrounding plains. Scientists debate whether any of these volcanoes are still active today. There is some tantalizing evidence. Fluctuations in sulfur dioxide levels in the atmosphere, and some features that look like recent lava flows. Confirming current volcanic activity is a key goal for future missions. One major difference between Venus and Earth seems to be the lack of plate tectonics. On Earth, the crust is broken into several large plates. These plates move around, they collide, they pull apart. This process recycles the crust. It drives earthquakes and volcanism. It plays a crucial role in Earth's climate regulation. Venus does not appear to have this global system of moving plates. Why? Perhaps its crust is too hot and soft, or maybe it lost its water early on, making the crust too stiff and buoyant to subduct. The exact reasons are still a subject of intense research. The surface of Venus appears surprisingly young, geologically speaking. It has relatively few impact craters compared to other old surfaces like Mercury or our Moon. This suggests that something erased older craters. Most of the current surface seems to be only a few 100 million years old. Perhaps Venus undergoes periodic catastrophic resurfacing events. Maybe massive outpourings of lava completely repave the planet every few 100 million years. Or perhaps volcanism is more continuous and widespread than previously thought. Unlocking the secrets of Venus's geology is key to understanding its dramatic history. Section 7. Lessons from a hothouse Venus as a warning. Let's compare the temperatures of Earth and Venus directly. Earth has an average surface temperature of about 15 degrees Celsius or 59 degrees Fahrenheit. This is a comfortable range for liquid water. It's a comfortable range for life as we know it. Venus, our sister planet, has an average surface temperature of about 465 degrees Celsius or 870 degrees Fahrenheit. This is a staggering difference. One planet is a cradle of life. The other is a scorching inferno. This dramatic contrast, despite their similar sizes and origins, holds profound lessons for us. The key difference lies in their atmospheres. Both planets have greenhouse gases. Earth's atmosphere has a balanced amount. This natural greenhouse effect keeps our planet warm enough to support life. Without it, Earth would be a frozen ice ball. But Venus has an atmosphere that is over 96% carbon dioxide, and it is about 90 times denser than Earth's. This creates a runaway greenhouse effect. It traps an enormous amount of heat. It turned Venus into the hottest planet in the solar system, even hotter than Mercury, which is much closer to the Sun. Studying Venus helps us understand how planetary climates work. It shows us how a planet's atmosphere can determine its fate. Venus wasn't always like this. Early in its history, it may have been much more Earth-like. It might have had liquid water oceans, but something went wrong. Very wrong. Understanding this planetary-scale climate catastrophe is vital. It provides a natural laboratory for testing our climate models. We can see the extreme end member of what can happen when greenhouse gases accumulate unchecked in a planet's atmosphere. This makes Venus a stark warning for us here on Earth. We are currently adding large amounts of carbon dioxide and other greenhouse gases to our own atmosphere. We are doing this through the burning of fossil fuels and other activities. While Earth is not about to turn into Venus overnight, the Venusian example shows the powerful impact these gases can have. It underscores the importance of understanding climate change. It highlights the need to protect the delicate atmospheric balance that keeps our own planet habitable. Venus serves as a cosmic cautionary tale, written across the sky. Section 8, The Allure of the Inferno. Why we explore Venus. Why do we spend time, money, and immense effort to study a world as hostile as Venus? It seems like a planetary hell, yet scientists are drawn to it. One major reason is to understand planetary formation and evolution. We have two planets, Earth and Venus. They started out so similar in size, mass, and composition. They formed in the same part of the solar system. Yet one became a temperate haven for life. The other became a scorching, acidic inferno. Why? Answering this question is fundamental to understanding how planets in general become habitable or uninhabitable. Venus also offers a unique laboratory for studying atmospheric dynamics. Its atmosphere is incredibly thick. It experiences extreme temperatures and pressures. It has clouds of sulfuric acid. And it exhibits a phenomenon called superrotation. The upper atmosphere of Venus circles the planet in just 4 Earth days. This is much faster than the planet's own slow rotation period of 243 Earth days. Understanding the mechanisms that drive this superrotation and the complex weather systems within Venus's atmosphere can help us refine our models of atmospheric circulation on Earth and other planets. There is also the tantalizing question of past habitability. Could Venus have had oceans billions of years ago? Some models suggest it might have. If so, for how long? Could life have ever arisen there even if it was later extinguished? Searching for evidence of past water or geological features shaped by water is a key scientific goal. Understanding the history of water on Venus can tell us a lot about the conditions necessary for a planet to maintain liquid water on its surface over geological timescales. This is crucial for identifying potentially habitable exoplanets around other stars. Ultimately, studying Venus helps us understand our own planet better. It provides a contrasting case. By studying how Venus went wrong, we learn more about the factors that keep Earth right. It helps us appreciate the delicate balance of conditions that make Earth a habitable world. The search for life beyond Earth also benefits. Understanding the limits of habitability and the processes that can render a planet uninhabitable informs our search for life elsewhere in the cosmos. Venus, the goddess of love, presents us with a fiery, challenging, but deeply important scientific puzzle. Section 9, A Day Longer Than Its Year, The Strange Spin of Venus. Venus holds many secrets, and some of its characteristics are just plain weird. Here's one of the most fascinating. A day on Venus is longer than its year. Think about that for a moment. It takes Venus about 225 Earth days to complete one orbit around the Sun. This is its year. So if you lived on Venus, your birthday would come around every 225 Earth days. But it takes Venus about 243 Earth days to rotate once on its axis. This is its sidereal day, the time it takes to spin 360 degrees relative to the distant stars. This means a single day on Venus, from one sunrise to the next, a solar day, is also very long. It's not simply 243 Earth days because Venus is also orbiting the Sun during that time. And it rotates backwards compared to Earth and most other planets. This is called retrograde rotation. So the Sun on Venus rises in the west and it sets in the east. The time from one sunrise to the next on Venus is about 117 Earth days. Imagine a day that lasts for nearly 4 Earth months, and then a night that lasts for another 4 Earth months. Why does Venus spin so slowly and backwards? This is a major cosmic puzzle. Most planets in our solar system rotate in the same direction they orbit the Sun. This is called prograde rotation. It's a consequence of the conservation of angular momentum from the original cloud of gas and dust that formed the solar system. Venus is an oddball. Uranus also has a strange rotation, tilted on its side. But Venus's slow retrograde spin is unique among the terrestrial planets. What could have caused this? Several theories have been proposed. Perhaps Venus was struck by a massive object, a planet-sized body, early in its history. Such a colossal impact could have dramatically altered its spin. Or perhaps the gravitational pull of the Sun, acting on Venus's very thick atmosphere over billions of years, created atmospheric tides. These tides could have gradually slowed its rotation and even flipped it over. Or maybe a combination of factors was at play. Whatever the reason, this strange rotation adds another layer of mystery to our enigmatic sister world. Venus continues to challenge our understanding of how planets form and evolve, right down to how they spin.